a flash brighter than every star in the sky, from a point smaller than a single atom. 1 second ago, that was a black hole. Now it's dead, releasing more energy in that instant than all of humanity has produced in its entire history. And every black hole is headed for the same end, the monster at the center of our galaxy, the one pulling on the night sky above you. All of them dying, which should be impossible. Nothing escapes a black hole. Not light, not matter, not you. That rule has never been broken. So how does a black hole die? To see why that's impossible, remember what a black hole really is. A region where gravity is so strong that nothing escapes. Cross the edge, the event horizon, and you are gone from the universe. Forever. It should only ever grow. It eats gas, stars, light, and keeps all of it. It should outlast every star, every galaxy, maybe the universe itself. A permanent scar in space-time, a one-way door with no key. For decades, that's exactly what physics told us. Black holes are forever. Then, in 1974, a young physicist named Stephen Hawking found the loophole. And it changed the fate of everything. Hawking's idea begins with a strange truth about empty space. Empty space is never truly empty. At the smallest scale, it's a boiling ocean of activity. Pairs of particles flickering into existence and vanishing again, everywhere, all the time. Normally a pair appears, meets, and cancels out in an instant, net zero. The universe never notices, but right at the edge of a black hole, that dance goes wrong. One particle falls in, the other escapes. With no partner left to cancel it out, the escaping particle becomes real. And becoming real costs energy. The universe demands the books be balanced. So the black hole pays the bill, out of its own mass. Think of a thief stealing a single grain of sand from a mountain every trillion years. At first, you'd never notice, but given enough time, even the mountain disappears. This is Hawking radiation, a faint glow bleeding off a black hole. We've never detected it directly. It's far too faint, but it's one of the most trusted ideas in physics. The rare place where the very large and the very small finally agree. Which means every black hole has an expiration date. But here's where the story turns truly strange. You'd think the biggest black holes would die fastest. The opposite is true. The smaller a black hole is, the hotter it glows and the faster it dies. The bigger it is, the colder and slower it gets. And the giants are cold, almost unimaginably cold. So cold that Hawking's math hides a twist. Take Ton 618, the monster from our last video, 40 billion suns. Right now, it's colder than space itself. The universe is still faintly warm, glowing with leftover heat from the Big Bang. And Ton 618 is so cold that it absorbs more of that heat than it leaks away. Which means the largest black holes aren't dying yet. They're still growing. Their countdown hasn't even begun. It only starts once the universe expands and cools below their own temperature, far, far in the future. And when it finally does, Ton 618 would take around a Google years to evaporate. A 1, followed by 100 zeros. The universe is 13.8 billion years old. Against a Google years, all of cosmic history, so far, isn't even a single heartbeat. Black holes won't just outlive the stars. They will be the last things left in the universe, the lords of a dead, dark cosmos. And then, even they will fade, because evaporation feeds on itself. The smaller a black hole gets, the hotter it burns. And the hotter it burns, the faster it shrinks. A runaway loop with no off switch. For most of its life, the leak is agonizingly slow, but in the end, it turns violent. When a dying black hole shrinks down to roughly the mass of a large ship, it has about 1 second left to live. In that final second, its temperature rockets to millions of degrees. The slow leak becomes a flood, and it ends not with a whimper, but with a single, brilliant explosion, a final flash of gamma rays, releasing more energy in 1 instant than all of humanity has produced in its entire history, from a point smaller than an atom. Then, nothing. Where something once trapped light itself, there's only quiet, empty space. And this isn't only theory, waiting trillions of years away. Tiny black holes born in the chaos of the Big Bang could be hitting that final second right now. And astronomers are scanning the sky for the flash. Zoom out far enough, and Hawking radiation tells us how the universe itself ends. First, over trillions of years, the stars burn out. The galaxies drift apart and go dark. Then, for an era so long it makes everything before it look instant, black holes rule a cold and empty cosmos, faint, lonely, slowly bleeding away. And one by one, from the smallest to the very largest, they evaporate, they flash, they vanish, and they leave behind nothing but a thin, cold mist of particles drifting through endless dark. No stars, no black holes, no heat, no change. Scientists call this the heat death of the universe. It isn't certain, but it's the leading picture of how everything ends, not with a bang, with a slow, silent fade into the dark. So, can a black hole die? Yes. Even the darkest, most permanent prisons in the universe eventually unlock. And if black holes can die, then nothing is truly forever. Not even the cosmos itself. Does that terrify you? Or is there something strangely beautiful about it? Tell me in the comments. I read them. If these cosmic mysteries keep you up at night, subscribe. I chase a new one every week.